Many see progress and environmental protection as competing priorities, where one must always be chosen over the other. At ELOS, we see things differently. We see a partnership, a balance between improving the quality of our lives and preserving the places we call home. Our services make it possible for projects to move forward while also ensuring that they comply with all laws and regulations, that sensitive wetlands are not damaged or destroyed, that endangered species and habitats are protected, and that invaluable cultural resources are preserved for future generations. This is where we live, where we play, where we raise our families. We strive for a brighter future, but remain committed to the lands we love. ELOS, where natural environments and human interests intersect.
Good afternoon, everyone. My name is Bud Faust, Marketing Coordinator here at ELOS Environmental. Thank you for joining us this afternoon as we take a look at the effect that Lidar technology has had on GIS mapping. Just a couple of quick housekeeping items before we begin. First of all, we are recording this session and we will be sending you a link to it once it's uploaded to our YouTube channel. If you'd like to rewatch or pass along to any colleagues or anyone else you think might be interested in the content. Secondly, we will be taking questions during the presentation through the chat box, but we will not answer questions until the end of the presentation. But you can feel free to submit any questions during the presentation itself, and we will address them at the end of the presentation. Also in the chat box, you should see 3 email addresses, one for myself and one for each presenter. Should you have any questions after the session is over or something pops into your head, feel free to drop us a line and we'll do our best to get you an answer to your question. Again, thank you for joining us. And with that, I will turn it over to our presenters.
All right. Good afternoon, everyone. And again, thank you for joining us here. Some brief introductions, I believe, are in order for those of you who may not be familiar with either ELOS or the presenters here today. So ELOS, we're a Louisiana-based firm. We were established in Hammond, Louisiana in the year about 2006. We've been around for about 18 years. We currently have 2 locations. We've got our primary main location here in Hammond. If you look at the picture on the screen, this is our main office. And we have another satellite office in Thibodaux to service clients more on that side of the state. We do the majority of our work is here in Louisiana, but we do work throughout the Southeast United States in various areas with various clients. We work with a variety of clients from state level to parish to local level, small businesses to corporate and industrial clients. So a variety of people we work with. And as part of that, we strive to use innovative techniques and technology to best serve our clients. And one of those things that we use is both GIS coupled with Lidar technology. So I'll pass it to Adam to introduce himself.
Thank you for that, Drake. As he said, my name is Adam. I'm a coastal scientist here with ELOS. I have my master's degree in oceanography and coastal science from LSU. I'm currently pursuing my PhD as well, and I do have a graduate certificate in GIS. Some of the work that I've worked on for ELOS, restoration projects. With that, I use a combination of research and GIS to analyze satellite and LiDAR data to better understand and present the changing environment within the coastal Louisiana region.
And I'm Drake Arnone. I've been at ELOS for about 7 years now. I'm an environmental scientist by education. I graduated from Southeastern here in Hammond, so I'm happy to be with a local firm. It's really been a blessing and an honor. When I started out, I did a lot of field work. I did wetland delineations, cultural resource and archaeological digs, which were very interesting and fun. Phase 1 environmental site assessments, things of that nature. Shortly thereafter, after the floods of 2016, I became a lead-based paint risk assessor and asbestos inspector to help with disaster recovery efforts. A lot of the homes needed to have that documentation. And now with all that different experience, I've taken that and become a project manager to assist clients, make sure their needs are being met by our project teams. So that's it for our brief introductions. We appreciate your patience on that, and it's nice to meet you guys. So lay a little bit of groundwork here and talk a little bit about GIS, or Geographic Information Systems. For those of you who may or may not be familiar with it, there are dynamic uses for GIS, and especially when you couple GIS technology with Lidar and other types of data gathering technology, you can geospatially reference it back to where it's at on the planet Earth. In the not so distant past, a lot of these types of things had to be done by hand-drawn maps, and then any data points would have to be referenced by hand on that map, which could be very inconsistent, first of all, depending on who may be drawing the map. It could be somewhat inaccurate as well, and the data could be difficult to use. If you send someone into the field to go look at that certain location, it may be difficult to actually find that data set. And lastly, it could be very difficult to database and manage all of the data that you collect when it's not in digital form, when you have physical data that you've collected. So GIS technology helps to alleviate some of those shortfalls from the past. It makes, any map figures or data sets much more consistent. When coupled with global positioning technology, it can also be very accurate. So if you send someone in the field to go look at this data set, they'll be able to easily go back and find it within a few feet accuracy of that data point. And lastly, it's much easier to store and database information whenever it's in a digital format. So the bullet points you see here are some of the types of data that can be processed and analyzed using GIS technology. We use this, as I said, on a good many of our projects. And as this picture illustrates, one of the main things that you can do is overlap layers of information. So oftentimes you'll start with a base layer of an aerial image, and then you'll overlay different data sets so that you can reference it to where it's at geographically. And so, like I said, we use this in a good many of our projects. One thing that I will say, as I mentioned before, is databasing this information is made much easier through the use of GIS. Those data sets can actually be transmitted via a zip file directly to someone else. And there are also online versions where a live map can be shared, and the user on the other end can actually access the data in real time. So people can be collecting data in the field, and it will show up in real time for those who are analyzing it on the other end. So now we'll talk a little bit more in depth about Lidar specifically, and we'll talk a little more about this picture here, but a little hint, this is a city that was undiscovered for a long time. So with that, I'll pass it over to Adam.
So LiDAR, that's how we commonly call it. But what it is actually is light detection and ranging. And it's a method using lasers to determine distances. A couple of the components in a LiDAR system is the laser source and the detectors. There's timing electronics. There's GPS for the positioning of the instrument itself. And then there's IMU, which is inertia motion unit. And that one will give you the X, Y, and Z coordinates to generate the point cloud data. And it's based on angle calculations. So it's ideal for detailed mapping and surveying. It was first commercially used in 1961 by the Hughes Aircraft Company. quickly adopted by the military, space agencies, and stuff like that afterwards. And there's currently a number of different fields that use it, including archaeology, as Drake had just mentioned with the lost Mayan city, finding lost buried cities, self-driving cars, military applications.
So, and to bring it back to archaeology and to look at some more specific uses of LiDAR, we've found a couple of examples with cultural resources of where LiDAR was used to really enhance the search for archaeological features. So the first example we found was in 2023, researchers used LiDAR technology to discover a vast network of ancient Mayan ruins in northern Guatemala. These ruins included about 964 settlements, 417 interconnected cities, and about a 100-mile network of raised stone trails and causeways. So in this, they estimate the settlement dated back to around 1000 BC or so. And so it had become completely overgrown in the jungle and was completely unable to be seen or accessed. And so the only way that they were able to find it was by using LiDAR data and noticing trends in the elevations that look like a city layout. Next, we have Angkor Wat. Some of you may be familiar with that site. It's been being studied over the past 20 years or so. And until more recently, it was still pretty poorly understood due to the limits of being able to access the site and really understand what's there and what it was used for. However, since LiDAR has been employed to start analyzing the site, it's revealed a very sophisticated city layout, which even included some highly engineered water management systems, which again would have been invisible to the naked eye without LiDAR. And finally, in the UK, they actually discovered some Roman roadways that had been buried and were undiscovered for a long time. In 2023, they used LiDAR to discover these around Devon and Cornwall in the UK. And the scans revealed new sections of roadways that were previously unknown. And it revealed that these roadways connected various military forts and other settlements. And their goal is to use these roadways to help identify potential for some unknown settlements. So wherever the roadways are going, there may be a settlement there in that vicinity.
Some other uses for LiDAR within the GIS spectrum is determining the bare earth elevation underneath the trees and canopy. This is useful because the aerial photographs that we get from satellites or other aerial imagery, it can make it difficult to understand what's below that tree canopy, especially if it's thick vegetation. We can also use it to define building footprints, measuring the heights of objects. This is especially useful when comparing trees and buildings to identify if trees are a threat to buildings, whether it be residential or commercial. You can use it for measuring slope, which is really beneficial in areas other than Louisiana because we're relatively flat here. But you can use it for measuring the riverbank slope and stuff like that, which is beneficial here. Some of the other areas where it's more mountainous and hilly terrain, identifying slope and possible slope failure sites for hazard mitigation and stuff like that. Flood risk assessments and disaster management and recovery are also some beneficial uses of LiDAR. For city modeling and planning, LiDAR can be really useful for identifying traffic patterns and pedestrian patterns and mapping those out. It's also extremely beneficial for smart self-driving cars and connections with those. The power lines and identifying hazards to power lines with the vegetation and maintaining good infrastructure for that as well. Some other geological uses for it would be identification of fault lines that we may not have known were there previously. Glacier mapping and movement and identifying where some faults might occur within the glacier and the ice sheets. Submerged landscapes and shipwrecks. There's a little caveat with this one. Green light is what's used for bathymetric Lidar used, because green light is able to penetrate the water a little bit deeper than your reds or your blues. The main caveat with this, though, is it can only go to about 2 times the visible depth, because the water does cut off the usable depth for the green light. So there is limited use in the coastal regions. However, we do still have that ability to use them.
So another big place where LiDAR has really enhanced the capabilities is in forestry management. So LiDAR coupled with GIS has really become an integral part of that. It allows foresters to collect data remotely and be able to analyze that data for any trends or significance that they may have. So, for example, they can look at the canopy height of their growth stand that they've maybe planted a while back, and they want to know what's been the change over time. So they can measure the change in canopy height over time to ensure that growth is happening at a certain rate, along with being able to measure the biomass, which is another very good indicator of the health of that growth stand, and can also determine what amount of carbon could be stored in those trees based on their biomass, their canopy height, and things of that nature. And that can be very important for carbon sequestration projects, which have become a hot topic as we try to lower greenhouse gases across the world. You can also send data to any loggers or field crew. So the data can be analyzed remotely, and then information can be very quickly sent to people on the ground to be able to give them direction or let them know maybe where to cut trees or where attention is needed within the stand to make sure that it's healthy. So I do want to point out while we're on this slide, and something that we mentioned, but I want to talk a little more about it, is that you have different returns can come back, which allows you to measure the density of the canopy as well as other types of data. This is just one example, but the laser, the light may hit different objects and actually send a return. And then the final return, as Adam mentioned earlier, will be your base elevation. And from that, you can produce a digital elevation model. And those are very important for all types of work. It's very useful in being able to identify features within the geology.
So continuing with that, here we have an aerial photograph image of heavily treed canopy area. There appears that there might be a river going through here. We can see kind of in the middle of this black area. Although from the aerial, it's difficult to exactly pinpoint what's going on there. So you would have to do some ground truthing with this, just to ensure that there is a healthy river there. Yes, it's there. There are tributaries, and they're at this location, and this location. So it would take more coordination if we're just using the aerial photograph. However, as we can see here, with the use of LiDAR, we can strip away that vegetation layer and the canopy and really be able to understand what's going on at that base layer or the DEM. And we're able to see that, yes, in fact, there is a nice healthy river going through here. There are tributaries that are clearly visible. Looks like some relic, oxbow going on through here. And then you're able to produce a final map where it highlights the actual river, some cut banks, in different locations like that. And then you can use this information to help assess the wetland and the underlying soil and all of that to ensure that the health is there and that it's getting enough nutrients. Some flooding occurs, when it occurs, and when it would likely occur versus drought seasons and stuff like that.
So, just to further parse out some of the uses of LiDAR and how it can help, to go back to our example here with the waterway. So when you have a waterway that has a lot of foliage over it, LiDAR penetrates that. And what it can do is it can actually reveal down vegetation within that waterway and help you to GPS pinpoint locate that, which can allow crews to get out later, remove that debris, and help enhance the flow of the waterway. So it's hazard mitigation to make sure the drainage is still working correctly. But on top of that, it can also be used to measure damage or assess damage on structures as well, especially if there are before and after LiDAR data. You can see where maybe a roof is sagging, for example, things of that nature. With wetlands, again, our river example is a very good example of that. From looking at the aerial image to a trained eye, at times you can use vegetation to understand that there may be wetlands, but being able to see that elevation and see low-lying areas within your project site can really help to identify wetlands before you even have to go into the field and ground truth that information. It can also be used to help identify flow lines for hydrologic studies. So if you want to understand how does our watershed flow, where are the basins, where are the lowest lying areas, you can see those flow lines and those trends based on the changes in elevation revealed by that LiDAR. Also mentioned archaeology. Not only can this be used in jungle or forested areas, but it can also be used in places like marsh areas, like here in Louisiana. There may be Native American settlements there that are otherwise hidden, but there may be slight elevation features that can help reveal that. Or even in places that are like a desert that are sandy, it reveals those elevation changes that may show a pattern of something significant. You've also got coastal management and monitoring, something that's very big here in Louisiana. So collecting this LiDAR data over time can help entities like Coastal Protection and Restoration Authority understand where is the most erosion happening, where do we need to focus our efforts on our coastal restoration projects. And then, of course, LiDAR allows for very quick data collection. One of the main things that we've been stressing is it keeps you from having to necessarily go into the field to get some of your data. So LiDAR data can come either from satellite data. You can also fly over with an airplane equipped for LiDAR. And there are also drone applications now that can be attached to a drone, and a project site can be flown specifically to get even more fine detailed data for that. And finally, habitat mapping. So understanding the change in elevation can help you know if you are likely to encounter a certain type of species in that area. So some species may like lower lying areas, whereas other species may like areas of higher elevation. This can help you understand where those areas might be within a project site.
All right, at this point, we'll take any questions that anyone has for either of our presenters, feel free to type your question into the chat box and we'll get it answered for you. Apparently, our presenters were so amazingly wonderful that they answered all of your questions. I'm not seeing any in the chat box. Yes, the session was recorded, is being recorded. We will be uploading it to our YouTube channel in the next couple of days, and we will be sending out links to you all to view if you missed a portion of it, or if you share it with any colleagues or anyone in the field of GIS or anyone who you think would be at all interested. We also do this webinar series on a monthly basis, so you can check our website, elosenv.com. You can also follow check our social media accounts on LinkedIn and Facebook to see what our next topic is going to be. Someone is asking if they can ask their question verbally, and unfortunately you cannot, as the settings of the webinar prevent that, but we would certainly love for you to type in your question so we can get it answered for you.
I would say also, if you have a question, feel free to email myself or Adam, and we could always set up a phone call and talk with you as well. We'd be happy to do that.
Absolutely.
Okay. You do, I assume, this would be, Randy. You do see the email addresses at the top of the chat box. You can reach, any of us there, and we will do our best, to answer your question. Or as Drake said, set up a call with you if that's necessary. Does anyone else have any other questions before we conclude the presentation? All right, I'm not seeing any additional questions. Tracy, thank you for attending, and you're very welcome. I hope you found it informative. Thanks to everyone for attending today. And again, we'll be sending out a link to the video if you need to watch it again or share it with anyone you like. We appreciate you coming today. Hope you learned something. And if there's anything we can do to help, please feel free to reach out. And with that, we'll say good afternoon and enjoy the rest of your day.
Thank you, everyone.
Thank you all.